The first thing that we're going to add is the lantern block, the big one. Let's first make an albedo texture or so. We're opening this up in Illustrator. So you can kind of see that what Space is Green intended here was for light to reflect on these surfaces over here. I was thinking along the same lines. How will it reflect? The light is inside of it. Here's the deal. This is the perfect texture for me to show this effect off. It's going to look amazing. This is the lantern block. Boop, boop, boop. This is sort of the back. We have the texture applied on top of this. So it's kind of like this, this kind of design, sort of with the grating going on. There we go, and we have this center portion. This is light, this is light, this is light, this is light. So the calculated light is going to be in red here. The center of the cube, so this is the exact center of the cube, it will say, okay, this has a lot of light going on, because this is the center of a lantern block. It's actually a light source, so there's a lot of light radiating in all directions from this block. So what it will do for these pixels over here, it will say like, okay, where's your nearest light? It's the block itself. So it will actually point inwards and say your nearest light is here. For this point it will say your nearest light is right inside of you. What we now want to do is to make the sides of this lantern block point inwards so that it actually reflects its own light outwards. And this is going to be green. There's all kinds of colors going on. The idea is that this light source, so the center of the voxel, radiates outwards to the rim of the lantern, and that reflects like this into our eye. This is our eye. Check it out. See, that looks like an eye, yeah? Yeah. If this works, it's going to look so sick. Now we just have to convert that into a proper 3D representation using our normals, using our displacement. For the albedo channel, we're going to use steel as a base. It ranges from 37.5, so let me zoom in. The value ranges from 37.5 to 85. Let's do the math interactively. 37.5 plus 85, and we divide that by 2, and we end up with 61.25. This is on a scale of 0 to 100, because it's a brightness value. We divide this by 100, and then we multiply by 255 to get the byte value. Red, green, and blue channels need to be 156. So let's enter that here. 156, 156, 156. But if you've been paying attention, I now assigned an sRGB color value to this albedo channel. Albedo maps now need to be in linear color space. So instead of using 156, we have to convert this to linear color space. We had already made a material value calculator for making relative value changes. I also added a sRGB to linear converter here. So if we have an 156 sRGB byte value for colors, in linear color space that is 87. This is the base linear color value of steel. Now we need to find a way to fill in these edges. So let's make it our correct dimension of 480 by 480. We add it to our texture packer folder. There we go. We can make a material map. The red is the albedo mix, so red is going to be 0 for the light, because we already have the correct color for the light itself. Green is metallic, so it's not going to be metallic, and we want to err on the low side, so that's going to be 127. We don't really want to influence that, and we don't want to influence the roughness either. And now the background, this is going to be albedo mixed, because we want to use the steel color for this instead of the light color, so that's going to be albedo mix 255 on the red channel. Then we want it to look like the next channel is metallic. It's going to be super metallic, 255, there we go. And then we need to define the roughness for this. So now we compare the roughness factor of glass, which is 0.0, and steel is 0.15. The steel is a bit rougher than glass, but not much. So we can use our conversion tool again. We want to add 0.1, and then we have to use 140 for the roughness channel, which is the blue channel. 140, there you go. So now what we have to do is to make the ambient occlusion. We have to make a displacement map. We're going to go with a very simple displacement map. The light is slightly behind the steel for now. So let's go with 250, which is just off of complete white. And then we make the background completely white, like this. It's just a subtle difference. We call this the displacement. We fire up Pixplant, open up the displacement. We want it to tile in both directions, and we're going to extract the ambient occlusion map. Lantern block large PBR AO, if I'm not mistaken, PNG file. Now we add the ambient occlusion to our material map, 480 by 480 in the center of the artboard. So this is our material map for the lantern block. It's going to be added to the texture packer sheet, so there we have it. We're going to cheat the normal map for now. We're just going to make the normal map entirely flat. We now have a texture for the PBR style, so texture name PBR style is going to be lantern block large PBR, like this. Then we run the code generation to update our texture definitions for the materials, and we run our texture converter to make the texture. Does it look good? Not yet. Like, yeah, you can definitely see the difference in reflection on the steel and on the glass, right? See the difference in reflection? It's not only like the size of the highlight, but also the coloring on it. So this is where the irradiance comes in. We're now going to have to add this irradiance property to the lantern block, to the texture itself, instead of the material. Irradiance or emission is going to be mapped to the alpha channel of the normal map. Now the emission map itself is going to be very uninteresting. So the background is not going to emit light, and it's a bit counterintuitive, but that's going to be fully bright. And parts that are emitting light are going to be fully black, like this. So we are in our normal file, select this thing, add transparency, we place it from the emission map. So now we're up to 9 files for this texture, so definitely defining even more properties here. And we also scale this one down to 480 by 480 in the center of the canvas. Enable transparency while saving. Okay, we have something going on. What is up with the shading, I have no idea. But they are brighter, so that's the cool part. That's the good news. Looks like we're going to have to debug something. We're going to open up our texture file, the one that is being written by Texture Packer. Illustrator might optimize the texture to discard color information if the pixel is fully transparent. I'm going to do one quick hack here. So instead of making it entirely 0, let's make it halfway with the emission, 128. I just want to make sure that we're not running into a 0 alpha is 0 color situation here. Yeah, check it out. So they now actually appear as if they're giving off light. Now what we can do is maybe we actually use this as the emission, but we also add the globe in the center. So let's get this sphere or this circle in the center, and let's try to make that even more light emitting. And I think that looks pretty convincing too. So now we need to draw the normals. But like this is a flat portion, the center line, and then these are angled outwards. I think that's the sort of shading we want to go with. We also need to pay close attention to which part of the lantern is going above and under which other part. We have a reference, we have our background and our light definitions. So the outer rim seems like a very simple starting point. The normal map is more subtle now. You can already see a huge difference compared to using the second rung, as we called it. A pretty solid reflection here. It definitely looks like steel. The normal map is now absolutely fine for this texture. So let's make a new displacement map. Make a displacement map, they said. It will be fun. So this is like the ultimate attempt to make them look good. Extract ambient occlusion. It doesn't change a whole lot, so what's up with that? We can debug the thing here, so let's open up the occlusion, see what we look like.
Oh, no time to waste, let's go.
That is unexpected. Have we been doing everything wrong once again? We have the metallicness going on. Metallic shouldn't be fading out depending on what the ambient occlusion value is there. Our metallic map is completely sharp. Yeah, so check out the roughness channel. What's up with that? There's something funky going on with that ambient occlusion roofing tiles. No problems there. With the nails they look pretty good. Ah, we saved it without alpha value. We need to make sure that we enable transparency here. There we go. It's going to look way different now. The entire material was completely messed up. This is what it should have looked like from the start. Check it out. Oh yeah, this is looking good. Just a combination of these colors. I'm glad we were able to figure out the rendering error, and we ended up with a great texture. I believe it really does justice to the new rendering and to the new engine that we are making for this.